Today we're going to solve quadratic equations with non-real solutions, which it makes me so happy because this is a type of numbers that I like dealing with, and I visualize a lot. Well, not visualize, but like as in it's easy for me to recall them. But hopefully it's the same way for you. So let's go ahead and get started. We have been dealing with quadratic equations. Again, this is a two-variable equation where the highest degree is 2. And we have some examples and non-examples. I already went through this, so let me go ahead and go on to our next section. So in this in this part of our lesson, guys, we are going to have to recall the product of property of square roots. So if you guys remember that whenever we have a square root of a number, if that number has two factors, so for example, it can be square root of 25, right? And or actually, you know what, the square root of, let's see, 24. Let's do 24. We can go ahead and separate that that square root into two different factors. So for example, we have square root of 24. We can go ahead and separate that into two factors, so 4 and 6. 4 times 6, and my tablet for some reason is slanted, and separate their square roots, but we're still multiplying. It's a product, right? If they're multiplying, this will now become 2 square roots of 6 in that case. So we're going to go ahead and recall this part. The same goes with quotient property of square roots. Again, if we have a square root that is applied again to a fraction, we're going to go ahead and apply it to the denominator, the numerator, and the denominator, and then again simplify if possible. All right, so I'll go through the whole notion within the problem and recall those properties, and you guys will have practice within the problems. Okay, so with that said, we've been dealing with several methods. One of the methods has been by graphing, taking the square roots, and by factoring those 3. Then we went into completing the square, and we went with the quadratic formula. So yes, you can go ahead and use the quadratic formula to any type of quadratic equation. But again, it's important for us to know how to identify the coefficients to the variables and also that constant. So today we're going to go ahead and use several methods. Actually, you know what? One. We can go ahead and use the quadratic formula as well, but I'm just going to use one. And I'm going to go over this question here. It says, how many solutions can you quadratic equation have? Now, usually we've been seeing 2 solutions, but in case you didn't know, there's several other solutions that a quadratic equation can have. And remember that whenever we have a quadratic equation, we have it in standard form, ax squared plus bx plus c. We're going to go ahead and make sure that our solutions, or we're looking for when y is equal to 0. So that's when we start solving. We want to make that y variable 0, right? So what is it that we have? So we have here our standard equation. If we were to graph our quadratic equation, we make sure that we're only focusing on the solutions, and that's when y is equal to 0. So here is this graph. And in this graph, you're able to see that if you look closely, there's only one solution. Why is there one solution? Because that's when this graph crosses that x-axis, meaning that y equals 0 once, right? So in this particular problem, it only has one solution. Now, whenever it is below the x-axis, it crosses the x-axis, or you have values for y and 2 solutions. So we have 2 real solutions. Now, what if it's a different position? What if it's somewhere up here where it does not cross this axis? This is what we're going to go ahead and call non-real solutions, aka imaginary solutions. So those beautiful numbers are going to come up now, and we're going to call them imaginary numbers. And make sure you're taking notes, guys, because this is what we're going to go ahead and continue to see in the next session, too. So now we are going to be introduced to imaginary numbers. What does it mean? That it means that whenever we take the square root, right? We have that formula. We take the square root, um, and we take the square root of a negative number. All right. Is it possible for us to take the square root of a negative number? Well, whenever we square a number, it's always going to be positive, no matter if we're squaring a negative number, right? For example, 2 times 2, 2 times negative 2 will always be positive 4. So every time we square a number, whether it's negative or positive, its result will always be positive. Therefore, if we were to take the square root of a negative number, it is very likely impossible for it to be in the real number line. Therefore, we've created what we call our imaginary number. So then we're going to go ahead and imagine that it's possible for us to do the square root. And we're going to go ahead and make that square root of -1 equal to I. Now, what if we decide to do something else to that I? So from here, I is going to be equal to -1. All right. So whenever we see, the square root of -1, whenever we see I, we're going to go ahead and always think square root of -1, square root of -1. All right. So from here, let's go ahead and apply something else. So here we have I equals square root of -1. We're going to then take the square of both sides, square I, and take the square root of -1. What happens is that we basically do inverse operations on the right side. So the square root basically not cancels, but reverses itself. It does an inverse operation. And we go back to -1. So if we were to square I, we would then go back to it being equal to -1. All right. And we can go on and on and on. We can go ahead and do the I to the third power, I to the fourth power, and I to the fifth power, and continue going and ongoing and going and going. Right. All right. So let me go ahead and clear this out. And we're going to go ahead and go on to our first example. So our first example says square the following imaginary numbers and simplify. So here we have 6i, and we have to square it. So let me go ahead and write on the side that I equals the square root of -1. And we know that I squared is -1. All right. So let me go ahead and square my beautiful number. I can go ahead and apply that square to both numbers. Therefore, I have 6 to the power of 2, which is 36. And I to the power of 2, we already know that it's -1. So therefore, we have 36 times -1. It's -36. So this is important to know. Okay, so write this down on the corner of your notes, wherever you need to write it out, have it highlighted so that we know and remember that part. All right, let me clear. Let me go on to example number 2. Now we have -I to the square and the square root of 2. It says right here to square the following numbers and simplify. So let's go ahead and do that. Square. So let me go ahead and separate. I have -I squared times square root of 2 squared. And remember that I equals the square root of -1, and I squared equals squared equals, what did I say? -1, sorry. So here we have -I times -I, which gives me what? positive I. And over here we have square and square root times 2. So this is what? 2I. So if you need to separate and do everything step by step, go ahead and do so. All right. Let me go ahead and clear this out. Let me go on to our next examples. We're going to go ahead and now move on to then solving quadratic equations that could possibly and do have imaginary solutions. So let's go on to our next example. Example number 3, go ahead and write this one down. Solve and allow for imaginary numbers. We're going to go ahead and solve for the solutions of this quadratic equation. X to the power of 2 plus 12 equals y. And I'm going to go ahead and show you how to do it one way, and then possibly I can go ahead and show you the different way. But again, you can go ahead and apply whichever method you prefer. You can go ahead and complete the square, quadratic equation, quadratic formula, or taking the square roots again here. All right, so I'm going to complete this by, let's see, taking the square roots on both sides. So how do I do that? First things first, I have to make sure that my equation is equal to 0. So I need to substitute that y by 0 because I need to know when y equals 0, right? So x squared plus 12 equals 0. Now, I'm going to take the square roots of both sides, but I need to move all the constants to the other side in order for me to do that. So let me go ahead and do that. X squared, I need to subtract 12, subtract 12. I have x squared equals negative 12, right? Now, I'm going to take that last step, which is to square root both sides. I'm going to have x equals, remember that whenever we take a square root, we have plus or minus the square root of 12. Sorry, negative 12. I need to simplify. The reason why is because I have a square root of a negative number. Now, how do I write this? I'm going to go ahead and separate because I do have a number and I do have a square root. So I'm going to go ahead and separate that square root, or the property is going to apply here that I was telling you guys about. So x equals plus or minus, don't forget your plus or minus, square root, my first number that I'm going to see, or the factors that I'm interested in. Notice that it's either negative 3 and 4, and this would be, oh my goodness, would be negative 1 and 3. So I do have all factors out. So let me see. I'm going to go ahead and do first one, 4 times the square root of 3 times the square root of negative 1. So notice that I did negative 12 and I separated them all into separate square roots because I'm allowed to do that by the product rule. Now from here, I'm going to solve for this one. Plus or minus 2. This one's already a prime number. It does not have a square root, so we leave it as square root of 3. And we know that I is equal to the square root of negative 1. So this would be I. And that would be our solution in this case. X equals plus or minus to the plus or minus 2 square roots of 3, I. And you can go ahead and set it up or write it out as a notation set. So you have positive 2 square roots of 3, I, and negative 2 square roots of 3, I. Whatever you prefer, or if you want to state them separately, x equals positive square root of 3i and negative 2 square roots of 3i in this case. Either way that you present it would be correct. Ouch. And this is taking the square roots of both sides. How do I know which method to use? It is up to you, whichever one you want. However, if you notice here, I do have my x to the power of 2 and a constant. So it's easier for me to solve it that way. Otherwise, you can use the quadratic formula or completing the square. But completing the square, you need that. Actually, you don't need it because you would add it on both sides. But however you wish to do it, we're going to go ahead and continue to use this method. Okay, let me go ahead and save. If you need me to come back to this, I can go ahead and do so. I'm going to go ahead and clear and go on to example number 4. This one says, again, solve and allow for imaginary numbers. We have 1/4 x to the power of 2 plus 9 equals y. Again, we're interested to know when y is equal to 0, even though this equation might not go through the x-axis through that y equals 0 line. So let's go ahead and rewrite it. 1/4 x to the power of 2 plus 9 equals 0. I'm going to move all the constants to the right side by doing inverse operations. Eliminates on my left side. So I'm left with 1/4 x to the power of 2 equals 9. Notice here that x to the power of 2 is not isolated yet. We do have to isolate it. What do? Multiply by the reciprocal, 4 over 1. 4 over 1 eliminates that or simplifies that 4 or 1/4. We're left with x to the power of 2 equals -9 times 4. -9 times 4 is what? 36. So this would be then taking the square roots of both sides. And we're left, let me go ahead and bring my work up here. X equals plus or minus, not forget this part, square root of -36. Now, we already know that 36 does have a perfect square, or at least I hope you guys were able to see that. But we have -36, so I'm going to separate it so that I'm able to take out that imaginary or that negative square root. So x equals plus or minus square root of 36 times the square root of -1. Again, this is 36 and -1. I'm interested of just taking out the -1 out of there. Katya, what did you do with the plus or minus? So because we take the square root of both sides, we know that we have a positive solution and we'll have a negative solution. So once, when you take the square root of one side and the other side, we've been doing that whenever we take square roots. It's also in the quadratic equation, b negative b plus or minus square root b squared minus 4ac all over 2a. If you are to identify the a, the b, and the c, the negative and plus or minus will still remain there. And I'm just doing by taking square roots of both sides. I'm not using the quadratic formula. Again, you're free to use any form here. Okay, let me simplify this. X equals plus or minus square root of 36 is 6. And the square root of -1, we know that it's I. So we have two solutions here. And you can go ahead and do it in solution set where you have 6i and -6i. Or list both solutions, 6i and -6i. Do you want me to do the last one by using the quadratic formula? It's up to you. I can go ahead and use the quadratic formula on the last one. But you'll compare and contrast. It'll still give you the same result. You'll be able to compare and contrast. Okay. All right, let me go ahead and save an image of this. So if you guys need me to come back to this image, I will be able to. I hope everybody has this. Okay, let me go ahead and clear. Sounds like we're doing the IED clear. All right, so we have here example number 5. It says solve and allow for imaginary numbers. I'm going to solve this one by using the quadratic formula. Again, you don't have to, you could, but again, I want to show you guys a different method. So, well, we already have a different method, but using our quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. All right, and this is x equals, right, our solutions. Now, let's go ahead and write this in standard form so that we know that we have our equation equal to 0. So let's go ahead and do that. Let me see, standard form. I need to subtract 10 on both sides. I have negative 5x squared plus negative, it would be minus 7 equals 0. And from here, I'm going to multiply my entire equation by negative 1 because I want to change the values because my leading coefficient has to be positive. So let me go ahead and do that. Multiply my left side by negative 1, multiply my right side by negative 1. Can I do that? Yes, you can. So I have plus 1, plus 1, plus 1. There you go. And the last one. So we have 5x squared plus 7 equals 0. All right, let me rewrite it so that I know what my middle term is. The middle term with our x to the power of 1. So I'm going to write 0x plus 7 equals 0 so that we can identify our a, our b, and our c. Notice here that our b is missing. It is present. It's just 0 in this case. All right, our a is 5, and our 7 here is our c, our constant. Okay, so now that we have every single term, I'm going to go ahead and plug it in into our formula. Let me start from up here. So we have x equals negative b. B is 0. We cannot have negative 0, so we're just going to go ahead and say 0 plus or minus square root b squared, 0 squared, minus 4. A is 5. C is 7. And all over 2a. 2 times 5. All right, let's go ahead and simplify. X equals, I'm not going to write the 0. I'm just going to go ahead and write plus or minus. Inside my square root, I have 0 minus 4 times 5 is 20 times 7 gives me what? What do you guys think? Which one was it? 140 all over 10 in this case. All right, let me go ahead and continue. X equals plus or minus the square root of negative 140, 0 minus 40 over 10. Here I'm going to separate, take out that negative 1, or the square root of negative 1. Notice that it is my factor's negative 1 and 140. I'm interested of taking that negative 1 out. So let me go ahead and rewrite it. X equals plus or minus square root of 140 and multiply it by negative 1. 140 then multiplies by what? We know we can take out 4, 5, and 7. 4, 5, and the last factor 7. So I'm going to go ahead and continue to spread that out. X equals plus or minus the square root of 4, square root of 5. Let me go ahead and rewrite that because it's too small. Square root of 4, square root of 5, times the square root of 7, times the square root of negative 1, all over 10. So continue to simplify. I know that this one will square 2, and these two will not be able to square. They're prime numbers, and this one I know will be I So this would be square root of 35 I over 10. One more step, last step before we're done, guys. X equals plus or minus. This would simplify then. 2 and 10 simplifies. I have plus or minus square root of 35 I over 5 in this case, and that's my solution. This is using the quadratic formula. Again, it would give me the same solution. And I can go ahead and show the other way too. The imaginary numbers are basically when we're taking the square root of a negative number. So notice here, let me go ahead and see. At this point here, 0 subtracting 140. It becomes the square root of negative 140. Because we cannot take the square root of negative numbers, that's when I comes into play. So if we have a square root of a negative number, we know that we'll have an imaginary solution. And again, it's a lot of practice on doing the square root of the properties there. That's why I included in part of the lesson. Here I separated it, yes, to see all of it. If you need to, you could, but if you don't have to do it all. But I did separate it to see what could possibly or what does have a perfect square. So for example, 4 had a perfect square, 5 did not, 7 did not, and negative 1 was the square root of negative 1. We know that was already I. So I placed these two back together. Notice that 5 times 7 is 35. And I left that square root of 4, which is 2, out. So if you need to break it apart, break it all the way until you go onto your prime factors and see what actually you can take out. You can go ahead and do your tree if you need to, if you guys remember the trees. Let's see, 140, 2, and is it 70? And you can go ahead and break it apart, 2 and 35. And we know that it's 5 and 7, and so on and so forth. So you know that we have a pair of 2, so we know we have 2, and then we'll end up with 35 inside. And again, this is recalling that algebra 1 part. Any questions on this? So again, go ahead and put yourself a recall on these properties. Any questions?